the last video what we did is we talked about what if I have a fraction? You do L'Hopital's on that, then you're good to go. But what if you're taking a limit, but you have a function raised to a function? How's that going to work? Well, how this is going to work is what I personally like to do. What I like to do is I like to say that y is equal to the limit as x approaches 0. And let's say you have a function raised to a function. Now this y, that's just what the limit is equal to. The limit as x approaches 0 of that function raised to a function is equal to some y, whatever it is. Now what you're going to do is you're going to be taking the natural log of both sides. The reason I want to take the natural log of both sides is so I can have this function up here and swing it down into the front. So from here what I like to do is I like to say that the natural log of y is equal to the limit as x approaches 0 of the natural log of f of x raised to the g of x, which, because of our properties of natural log, I can take this function that helps me swing this down. So what we're going to have is that the natural log of y is equal to the limit as x approaches 0 of g of x times the natural log of f of x. Now from here, let's do the limit. Okay, so do the limit. Just do the limit. And when doing the limit of this, the limit as x approaches 0 of that g of x times the ln of f of x, you're going to output some number. And on a multiple choice test, professors love to put that number, whatever you get, when taking this limit as an answer choice, and that's not correct. Because the natural log of y, the natural log of your final answer, will actually equal that number. Therefore, to find y, which is what I was originally looking for, I'm going to e both sides, and I'm going to say that y is equal to e raised to that number. Okay? So this is going to be our blueprint as to how to do it. And now with that knowledge, let's go ahead and actually do an example over here. So what I'm going to do is I'm going to go ahead and say that y is equal to the limit of, as x approaches 0, of 1 minus 5x raised to the 1 over x. Our first step, let's take the natural log of both sides. So what I'm going to say is that the natural log of y is equal to the limit as x approaches 0 of the natural log of 1 minus 5x raised to the 1 over x. And that's great, because then we can take this function and multiply it in front. So what I'm going to say is that the natural log of y is equal to the limit as x approaches 0 of 1 over x times the natural log of 1 minus 5x. But whenever I have 1 over x times the natural log of 1 minus 5x, you can just simply rewrite this. What I would do is I would take this and just rewrite this as the natural log of 1 minus 5x over x. And now let's go ahead and take this limit. Well, to take this limit, let's plug 0 into here. And when I plug 0 into here, I get the natural log of 1 minus 0 divided by 0. But the natural log of 1 is 0. Therefore, I get a 0 over 0. And because I'm a 0 over 0, we can go ahead and apply L'Hopital's. So let's go ahead and do that. Let's apply L'Hopital's. So applying L'Hopital's, what I'm going to get is the limit as x approaches 0 of the derivative of the top. So the derivative of the ln of 1 minus 5x is simply negative 5 over 1 minus 5x divided by, well, the derivative of x is, oh, just 1. So that's nice. Let's go ahead and plug 0 into here. And when I plug 0 into here, I get negative 5 over 1 minus 0, still all over 1. But all of that's simply just negative 5. And on a multiple choice test, man, negative 5 is going to be on there. So what you're going to want to do, or remember, sorry, what you need to keep in mind is negative 5 is that number. But remember, the natural log of y, the natural log of what you were originally looking for is -5. Therefore, to find out what that limit is, to find out what y is, you simply e both sides. And so when I e both sides, your final answer, y, which was your limit, is e to the -5.